we're going to use this formula and this known solution to find the second solution to this second order homogeneous differential equation with constant coefficients. Of course, when I use this formula to get the correct function for p of x, I have to make sure that there's nothing in front of the y double prime here. And I see this little 6 sneaking around. So I'm going to divide everybody by 6 so that the y double prime is by himself. Neglecting to do this step can lead to very big problems, because if you have the wrong function in front of y prime, this is not going to work out correctly, and it's just kind of a big mess. You definitely want this to be isolated first. Now this is my known solution, and I also know that my p of x function is the constant 1/6. Applying these to the formula gives me the second solution to be my known function, which is not that but this, times the integral of e to the negative integral 1/6 dx over that known solution squared. Using a little, well, if I integrate 1/6, it becomes 1/6 x. So my next line, this known solution is still hanging out here. Integral of e to the negative 1/6 x. And then if you take e to the x over 3 and square it, you multiply those powers together, that becomes e to the 2/3 x dx. Relying on my old rules from algebra, I can subtract these powers. I'm going to keep everything up on the top here. So what I'm going to do is actually pop this to the top with negative exponents. So the outside still is x over 3. Integral, popping that to the top, negative 1/6 minus another 4/6 is negative 5/6. So 5x over 6 dx. Integrating this guy is his own integral. There's, of course, a 6/5 negative constant that would come out to the front as well, but we do not care about these constants, so I'm going to ignore them and not write them down. It just makes my paper look messy anyways. And then when I multiply these two functions together, we're going to have to add these exponents. So I'm going to think of this x over 3 as 2x over 6. Add these guys together to get e to the negative 3x over 6. And after reducing that fraction, I see that e to the negative x over 2 is going to be my second solution. I do want to point out that you guys know another way to solve this. And this wouldn't be a bad time to just check your work using another method, especially if the other method is pretty quick. If I didn't know this or this, I always have the choice of saying this is equal to 6m squared plus m minus 1 equals 0. And then this quadratic factors into 3m and 2m to get the 6m. 1 and 1 to get the 1. And this would have to be positive, and this has to be negative to get the positive 1 in the middle. And from here, you can see we get values m equals positive 1/3 and negative 1/2, which exactly match the answers that we had in the first place. It's so nice when things work out from a totally different method, and if you get the chance to try that, you definitely should seize it, because most of life doesn't work that way, but this stuff does. Okay.